There's oil hidden 3,000 meters below the surface, and somehow we know exactly where it is. Without drilling, without digging. Not even a scratch on the ground. How? Because we figured out how to see the invisible. If you like exploring the world around you, subscribe. The hunt for oil begins high above Earth, with satellites. Why? Because when oil is trapped underground, it sometimes leaks upward, in tiny amounts. These natural oil seeps affect the soil, plants, and even temperature of the surface, but not in a way you'd notice. Satellites with thermal and multispectral sensors pick up these changes. They detect unusual heat signatures, maybe from gas escape, vegetation stress, since plants react to oil-contaminated soil, subtle discoloration or surface texture shifts. These are tiny, but from space, we get massive coverage, quickly. That narrows the search from thousands of square kilometers to a few potential zones. Now we get smart. We don't just guess. We use GIS, or Geographic Information Systems, to layer multiple types of information rock type, since only certain rocks can trap oil. Historical oil fields nearby, fault lines and anticlines, which are rock folds that trap oil, depth and thickness of sediment layers, and past drilling data from nearby wells. GIS acts like a brain that overlays all this data to say, here are 3 places worth investigating further. This is where modern exploration becomes targeted, efficient, and risk-aware. Now the real investigation begins, on the ground. We create small artificial shock waves using vibro-sized trucks, which shake the ground with a metal plate or small controlled explosions. These vibrations travel down into the earth and bounce back off underground layers. We place thousands of geophones, kind of like underground microphones, to catch the returning echoes. Just like how bats use echolocation, we use the echoes to build a 3-dimensional map of underground geology. This tells us how deep the rock layers are, whether there's a dome or trap structure, and if there's liquid or gas down there, because sound behaves differently through them. This is not guesswork, it's physics. Now, we double-check with passive methods. Gravimeters detect tiny changes in gravity. Oil is lighter than surrounding rock, so oil reservoirs make the gravity slightly weaker there. Magnetometers look for magnetic shifts in rock layers, helpful to identify ancient buried structures. These methods help confirm what seismic surveys suggested. Now the big question, even if we find oil, is it worth drilling? We assess volume. Is there enough oil to make a profit? Depth. Is it reachable with today's tech? Pressure and rock quality. Will it flow or be stuck? Environmental and legal risk. Protected land, populated area. Many potential oil fields are ignored because they are too expensive or risky to extract. A single well can cost $10 million or more. So unless everything checks out, no one digs. Once we're sure, drilling begins. This is when you see the classic oil rigs, but they don't guess. They know exactly where to drill, how deep to go, and what they expect to hit. The drill samples and pressure data tell us the final truth. And if everything aligns, oil starts flowing. From space to maps to waves to magnets, only then do we drill. The tools we use to find oil today can also find underground water, lost ancient cities, earthquake fault lines, even mineral resources for future tech. We're not just hunting for oil anymore. We're learning how to read the earth without disturbing it. And this is just the beginning. Subscribe if you want to explore how we're finding secrets beneath deserts, oceans, and even entire cities.